Good afternoon, everyone. It's a pleasure to welcome you to our latest DARE seminar. We have with us today Dr. Frank Iorfino and Dr. Rafael Oliveira, whom you both know very well. We've been a long-time collaborators. Frank is working at the interface of data science, health information tech, and psychopathology to develop decision support tools to assess and treat youth mental health problems. Rafa has been with us for quite some time, first in Fabio Ramos's group, then working with CTDS and DARE. His main specialties are Bayesian optimization and inference. He's now applying MCSA methods to estimate random effects models for longitudinal data in this youth mental health project. So I understand this will be a tag team, so we'll start with Frank. Please, Frank, take it away.
Thanks for having me. Yeah, so it'll be Rafa and I presenting. I'll give everyone a bit of a background about the problem and the cohort that we have and the data we have, and just to set up the work that Rafa will then go into some details about in terms of the methodology and the results. And so this work is funded by the Medical Research Future Fund grants, which is in explainable AI in youth mental health care. And the project has been, with myself and Rafa, but then also Roman March and Sally Cripps and Matt Veradell have also had major contributions as well. And the work is all about predicting poor functional trajectories to facilitate early intervention youth mental health care. And so we're interested in using some of the past data that we've had to improve how we make decisions about what types of care people get, so that we can intervene earlier and stop some of or prevent some of the poor trajectories that people experience. And so let me go to the next slide. So firstly, I'll just start with a bit about why we care about young people and mental health. So the prevalence rates of mental disorders prior to the age of 25 is quite high. And this is irrespective of whether you adhere to some strict diagnostic rules about what symptoms and thresholds and impairments levels get you into a diagnostic group or not. Most disorders do emerge during that time. And so you can see on the right-hand side here, the age of onsets, the typical age of onsets for most major disorders. And it's no surprise, this adolescent and young adulthood period is characterized by major physical and neurobiological changes. And so it's when we start to develop more higher order cognition and emotional functions. But it's also a time when people move from, relatively restricted and homogeneous environments at school or, with teachers, which has lots of structure, to environments that are characterized by greater independence and variability. And so these major social and physical and neurobiological changes means, that the people are vulnerable to the onset of disorders. And so that's why we see most disorders and most adult disorders, about 75% of adult disorders will emerge during young adulthood, so before the age of 25. And so that's why we see such high prevalence rates and these age of onset figures. And we know that the impact of just having a disorder during this period is quite burdensome and has long-term effects. So, for example, this graph here shows the disability adjusted life years. And so you can see these major peaks for depressive disorders, eating disorder, drug and alcohol use disorders, anxiety disorders, most between this sort of 10 to 35 or 30 age range. And this translates to things like lower workforce participation and living standards at age 30. If you had a disorder during adolescence and young adulthood, reduced income and greater marriage instability at age 50. And again, in mental health, we have this funny thing about diagnoses and, having a set number of symptoms before you have a diagnosis, and so these effects tend to occur even if the disorder was what we call sub-threshold. So it didn't meet full threshold disorder, but you could have, mild or moderate depression, or maybe on the cutoff of a formal diagnosis. And so these effects are quite significant, and the effects are also, even if the disorder's gone away. So you may have had an episode, it may have gone away, but the impacts are quite significant. And that's because if you think about it, you know, during that time is when we're trying to establish our careers, key social relationships. And so having these types of impacts during this period can have real long-term effects. And then just to go on to something even more serious in terms of leading causes of death, if you look at the age range for 15 to 24 and 25 to 44, suicide is the leading cause of death for people in these age groups, which again contributes to, you know, significant life years lost or early life from early death. So at the Brain and Mind Center, we've been engaged in a long-term study trying to establish what we call the Brain and Mind Youth Cohort. And so this is a cohort of people who have been presenting to what we call primary care services. So you may have heard of Headspace, and there are some other specialized services as well attached to them. So people are presenting for care. So they have some type of perceived need for care, which could be very mild, it could be very severe. And so that's why we cover a large range of mental health problems. So those with subthreshold disorders, as I've mentioned, but those with full threshold disorders as well. And the age range is about 12 to 30. And so these services, you can see the rough figures for different diagnoses. And in yellow, you can see sort of, you know, depression and anxiety tend to be the most common things people are presenting with, followed by bipolar disorder and psychotic syndromes, you know, at a much lower rates. And then you have a range of other sort of more of low prevalent disorders that go down that list there. So what we're primarily dealing with is people with mood, anxiety, and psychotic disorders. They're the primary syndromes, and then people tend to have some of these other problems which may have happened during childhood, like, you know, something like ADHD or autism as well, which then has maybe led to some depression or anxiety, or they may have some other sort of substance-related addictive disorders that have emerged as well. And just to go, so we, in terms of not focusing just on diagnoses, but we like to look at a concept called at-risk mental states as well. So these are types of symptoms and that indicate whether someone is at risk for a more severe sort of mood disorder, being, you know, something like bipolar disorder, or a more severe disorder like schizophrenia or psychosis. So these experiences may be experienced by someone with just depression, but they may have talked about having manic-like experiences or circadian disruption, which is something like sleep-wake cycles. And you can see that they're quite prevalent. So in at least 40% of the sample, they have some type of mix of one of these at-risk mental states, which just tells us that this is a group that are at risk for progressing to more severe disorders if early intervention and treatment isn't allocated. And so with that cohort, so that cohort is about 7,000 people, but we've established a longitudinal study on about almost 2,800 of them, where we asked if we wanted to follow these people up and see what happens to them over time. And over here, we've got most people, well, not most people, but we've tried to follow people over about 5 years. And so what we've done is we've established a baseline time point for someone, and then we've looked at trying to take little snapshots at different points in time by looking at their clinical notes at, say, like 1 month, 3 months, 6 months, 1 year, and then sort of between 1 and 2 years from then on as well. So to try and establish like what happens to these, what are these trajectories that people experience. And so at each of these time points, we have a range of variables, probably up to between 30 and 50 at each time point. And then so we get people's obviously demographics, but then we get details about what illness type they have and what might be their diagnosis. What are some of the clinical features? So like I've touched on before, some of these at-risk mental states. What is their functioning? So we have the measure that you may have heard of called the not engaged in employment or education or training, which is referred to as NEAT. So it's a measure of whether someone's engaged at work or at school, which is quite a good indicator of how much impairment the disorder might be having on someone's life. But then we also have another measure, which is like a composite measure of someone's social and occupational functioning. And this is measured by the SOFAS. So it's abbreviated to the SOFAS, stands for Social and Occupational Functional Assessment Scale. And it can be rated it can go down to from 0 to 100. So 100 being excellent functioning, someone's, performing in socially and occupationally at the best that they can. They're down to 0, which is probably quite rare, as you can see in this distribution. But so scores between, 30 and 50, people probably can't even look after their own hygiene at this level. So they're quite severely impaired in terms of their life function. Then you have this range here of about 50 to say 60, where maybe not that severe, but, they may be out of work, maybe not have many social relationships at all, or even sort of estranged from family and friends. So that type of impairment. This 60 to 70 range is maybe, they have some of these types of problems. They're probably in work, but maybe they're not working to the best of their ability, or they're having plenty of days off. And then you can see the green here is what we call the non-clinical or good functioning level. And so you can see there are people here on the cutoff. So these are people presenting for care, don't forget. So they have a perceived need. So it's no surprise that there are people in this sort of range just above the threshold. So we would assume that a large proportion of this group here are at risk for dipping below the line at some point. And then you can see there's a bit of a tail here where people are functioning quite well. And then you can just sort of see the sample, obviously diminishes, the numbers diminish over time. So at 3 months, we have about 1,600 people, and then 6 months, 1,200, 12 months, 1,000, and so on. So, and then there are some details here about sex and age. So you can sort of see the mean SOFAS here at baseline is about 62%. So right there, and it sort of maintains that even if we have the sample at, say, these 200 at 60 months, the data on them is still roughly sort of a similar mean there in terms of SOFAS. I think I've covered everything there. And so so just leaving SOFAS for a second, I just wanted to talk about some of the other needs that these young people experience. So we look at not just people's functioning, but we look at a range of different domains. So, everyone's very familiar with people's, depression and anxiety symptoms and those types of things, but we're really interested in some other things as well, like their suicidality, alcohol and drug use, their physical health, because these people that are presenting for care, they have, these quite diverse needs that go across a lot of domains. So, for example, you can see, about 1/4 are disengaged from work or education, 1/3 are in receipt of financial assistance. The majority, 60%, remain chronically impaired over time. Just pick out a few others. Up to 40% report previous history of self-harm. Smoking rates tend to be 2 times higher than the general population. Daily alcohol use 2 to 3 times higher. So you can see that there are quite a few different things going on for these people. And what this does is it complicates treatment, and it means that, and it can contribute to the negative long-term impacts of these disorders. And so it's quite a lot for services and clinicians to deal with when you can see you've got this complete person in front of you with this range of problems. Sometimes knowing what to do and how to intervene effectively can be challenging. And we know that people are at risk of progression to more severe syndromes. So this is work we had published with this cohort in JAMA Psychiatry. where we could see we have a staging model, which is a separate piece of work I won't go into in too much detail, but it's basically similar to what you might know about in cancer, where we try and stage people by the severity of their illness and how far it's progressed. And we can see roughly here the validation for our model, which is that, you know, stage one, people in early stages, 1A, are much, this is the rate at which they progress to stage 1B over sort of the 4-year period. And then the 1Bs to 2, which is a stage 2, is quite a significant disorder. And we know that young people with stage 1A have a lower risk of early progression to full threshold disorders. So we don't see many 1As go straight to a 2, you know, that usually progresses to a 1B. So you can see a large proportion do go to this 1B level, but then a lower proportion then progress to full threshold disorders, which is a really good, something we want to prevent. But we know that there's a subgroup of this 1A group that have more complex presentations. So as I mentioned, the at-risk mental state, poor functioning, or self-harm, these are all things that increase the risk of an early transition to 1B. And if someone's transitioning to 1B, that means that they also have a risk of transitioning to stage 2. And so I'm just trying to point out here that, you know, things like functioning and these at-risk mental states and self-harm and suicidality, these, in at least in this data set, have good predictive value in terms of predicting someone's chance of being on one of these poor illness trajectories, being progression to a more severe syndrome. But more relevant to social functioning, which is what the focus of Rafa's work will be talking about, is that some prior work of ours, which was just published in the Medical Journal of Australia, looked at what are some of the general trajectories over a 2-year period for people. And what we identified was that this blue group and this green group represent about 1/3 of the entire sample. So if you recall, I mentioned above 70 is good functioning and below 70 is that clinically impaired group. So what we have here is we have a group of people, about 20%, who tend to stay roughly at that high level most of the time. We have another group, slightly smaller, about 16%, who appear to improve over the sort of short to medium term, but then some of them have this sort of late recurrence. Sorry, I keep clicking the screen. But alarmingly, so for 1/3, you know, the current, you know, treatments that they're receiving in these services appears to be, you know, somewhat effective. But for the majority, this 2/3 in the orange and the red, either you're like the yellow group, where you come in quite impaired and you sort of stay on this persistent impairment group, which is about 16% again. And then there's this, you know, this hard to label group, to be honest. We ended up going with deteriorating and volatile, but I mean, deteriorating because there's this slight trend for decrease in functioning, but volatile because, as you'll see on the next slide, they sort of are a bit all over the shop, and there's quite a bit of movement up and down as over time. And so we did look at some things that were, you know, differentiating these groups. You know, this deteriorating and volatile group tended to be, you know, higher rates of disengagement when they enter the service. So these characteristics are all at baseline, so at 0. You know, they might have had more psychotic-like experiences, major physical illnesses and self-harm. And so what this seems to be pointing to is that these people have more comorbidities, more problems, greater complexity in their syndromes and the impacts it's having. And so it's not surprising that they need more comprehensive and multidisciplinary care, which is not really the mandate of the services they're going to, or what in the context of where this study has been drawn. So much more is needed for these 2/3. But which brings me to the problem that we've addressed today, which is that there's quite significant heterogeneity in the trajectories of functioning that we can observe. So if I just highlight the individual trajectory here for individuals in this deteriorating and volatile group, you can see the model is quite you know, over-inclusive in terms of where they fit in this model, and it's because we know that individual trajectories are difficult to predict, and determining when to adopt specific interventions and for whom is quite challenging. And for this, we do need more rich and continuous information about someone's outcome. So if you could just put your mind in the mind of a clinician, and when someone presents for the first time for care, you know, we don't know what trajectory they were on prior to us seeing them. So were they impaired and improving? Have they, you know, been on a stable trajectory, or were they good, and are they on their way down? And so part of what we really want to know is how, at this point, can we then determine whether someone's on this improving path, or whether they are actually at risk of deteriorating further, or having this sort of persistent impairment group, like in this yellow. And that's really what we're trying to do in clinical care, and what was the focus of this study today. So, you know, our hope is that we were aiming to develop probabilistic models of functional trajectories among young people presenting for youth mental health care. And so specifically, we wanted to combine some of the demographic and the clinical information that we know about someone at baseline to try and predict someone's functional trajectory and determine what might be the most likely trajectory for an individual, which with a particular interest in poor trajectory. So can we identify who's on this deteriorating path, or who is at risk for persistently low levels of functioning? And really the goal here is to inform the development of decision support tool that can be used to guide early interventions, because we can, if we know someone's on a deteriorating path, then there's no need to wait for that deterioration to happen before giving them a higher level of intervention, which may come at greater costs. So it becomes a better tool that can guide decision-making when to give someone what we call enhanced care, which does come at extra costs in terms of money and resource. And obviously, over time, we want to be able to use more data. So, you know, track people's functioning over time to constantly update information. But the focus here is on what Rafa is going to show you, which is trying to predict the trajectory of these levels of functioning. So that's the overview of the cohort and the study. I'll hand over to Rafa, who I think is going to go into detail about the methods and some of the results. Did anyone have any questions first about any of that before moving on? Maybe.
Can I ask how you cluster the trajectory? So you already clustered them, but it's manually done, or there's any?
In the previous work, so that was a previous study that we published, and that was using growth mixture modeling to cluster the trajectories based on it was a group-based trajectory modeling approach, and people were probabilistically assigned to a trajectory based on the predicted probability of what came out of the model. So that was a very basic work that we did initially to look at what were the trajectories, and then Rafa has definitely extended this a bit further and tried to go into detail about predicting specific direction of change.
Okay. Any other questions before we let Rafa continue? Okay, thanks, Frank. So, Rafa.
Can you guys see my screen and hear me okay?
Yes.
Okay, thanks. Cool. So just be talking now a bit about the actual model that we use for the Bayesian inference part of this work. It's a bit different from the growth mixture modeling that Frank has used in the previous study. In our case, we are actually going to be working for a random effects model, combining like a multinomial logistic regression with linear regression. And basically, we're interested in estimating the probability of individual to have the response to treatment, like the SOFA score. to be going up or going down or staying the same. And that's why you have these three clusters here. There's the constant cluster just means the person's response is not changing over time. And we are doing that over a short period of time here. So in this case, it's over a 3 months time window. Or ideally, we want people to have their response to treatment going up. But we also interested in detecting that the person has a high probability of going down, like in this figure here that's being shown now. So the model generates predictions like this, where like you've seen these magenta crosses, these are the actual data points of an individual. The black lines, they are the predictions from the model. So how the predicted posterior is for the trajectories of that individual. And on the right-hand side here, this is just the maximum likelihood estimates for the slope of that individual. If you just going to fit a line, there's this red line here. And the histogram just represents what the model is predicting. So it's just basically the takeaway here is that it can still assign a high probability mass to the actual rate of change for that individual, and then it can allow the model to detect whether the person really has a high chance of having the response to treatment deteriorating. So we are interested, right, again, in detecting whether the person is going to be going up, down, staying the same, and we model that via a linear regression model. It's just that this is inside the random effects framework, where we have Y being the response of an individual at a given time point, these beta JK here being parameters, the regression coefficients, 0 to indicate the intercept, so the initial response of that individual, the response of the individual had when they got to the clinic without any treatment yet. Beta JK1 is basically the rate of change that's multiplying the time frame here. So how much the individual would be, the model is estimating that this individual's response is changing over time. And epsilon here is noise that we're assuming to be a Gaussian noise, with parameters should be inferred. So I have a range of time points in individuals, and we are making all these coefficients to be conditioned on a cluster, the cluster being these three clusters we presented before, whether the person's response is staying constant, going up, or going down. And we do it this way because in principle, we want to make these clusters condition only on the covariates of the individual, right? So the needs category, whether the person has some childhood development problems or if they have any medical history, these are the covariates that we're going to be using. And we want to predict these regression coefficients based on the covariates. Right? So we model this by placing, in this case, in this model, an independent intercept model. So we assume that the intercept is independent of the cluster, although we also made experiments later, done some experiments later where the intercept was actually conditioned on the cluster. And the main thing is to condition the slopes, like so the rate of change of the response on the cluster. So for the constant cluster, basically putting a Dirac at 0. So assuming that's our 0 for people who are not changing the response. For the up cluster, we place a prior here and we put a hyperprior on these some of these parameters, and the down cluster is always a negative number. And using this gamma distribution so that we constrain the slopes to be always a positive change or a negative change, depending on whether the cluster is going up or going down, respectively. To assign individuals to clusters or to the up, down, staying the same, we are using this categorical prior. This basically you can transform that into a multinomial logistic regression model, where we are using the covariance of individuals, so the vector covariance that could include all these covariance that I talked about before, and a vector of parameters that we're also going to be inferring. So condition on these parameters and the covariance, we can assign a probability for the person belonging to a particular cluster, right? So for the parameters, we're placing a Zellner's G prior on this. It's just a technical detail, but just a fancy way of putting a Gaussian distribution as a prior for these parameters. It's just that we are scaling the covariance matrix of this Gaussian based on the covariance that we have in the data set. So if there are covariance that they have a range of value that doesn't change that much, this prior will automatically adjust to that. So we don't need to be individually tuning the covariance matrix for the parameters prior. In the end, we got a model that can be expressed as this graphical model here, where Z are the covariance of an individual. They affect the prior for the cluster assignment parameters and the clusters themselves. This B here is just the matrices of all the regression coefficients, and we have the noise here on the response. Y is our observed response of the individuals that we have in the data set. So you see that there's quite a few parameters here. Some of them are matrices, some of them are vectors, and it would be really hard to infer these like just doing optimization. This is a very high dimensional, and lots of things are correlated. So to solve this inference problem, we are running Markov chain Monte Carlo, and we are using the no-U-turn sampler. There's a more elaborate version of the Hamiltonian Monte Carlo sampler, which can use gradients of the posterior of the model to inform the MCMC proposals. So it can be very efficient in high dimensional models. So using that for the continuous variables and for the discrete variables like the cluster assignments, they just can take discrete categories. We apply a special Cripps scheme that basically transforms the posteriors for the individual, for the cluster assignments into a specific proposal that will combine that inside the MCMC scheme. Some of the hyperparameters we're tuning via Bayesian optimization. It's basically a black box optimization scheme that can do well whenever the evaluations are expensive. We can, in our case, to every evaluation of the hyperparameters for the model requires running the full inference. And we also try prior elicitation so that we can change the priors based on the models that we based on information that we have from combinations. It's just in the end, for this kind of model in particular, was a bit hard to get good results of prior elicitation because sometimes the priors ended up being too informative and not allowing them much freedom to the model to use the data to inform the actual parameters of the model. So I'm going to present now some experimental results. These are some marginal distributions for the posteriors. So this is child X, we call this the childhood, whether the person had or not childhood development issues. The Frank can probably explain better later. But if the person, if for a given individual, they didn't have childhood development issues, this is the predictions of the clusters for that individual. But you say that if the person actually had a childhood development issue, there is a much higher chance of them improving, and this can be a bit counterintuitive sometimes, but one thing to take into account is that the person that had childhood development issues, they probably got to the clinic with a lower SOFA score. So it's more likely that they will have improvements in their treatments, right? Instead of people who get there with a very high score, and it will be hard for them to go even higher. But there are some covariates that can reveal the things in the other way around. So one interesting thing that many of the models that we tried in this work revealed is that if the person has any sort of medical history, when they have treatments, is more likely that there's a significant increase in the chance, at least or lowering the chance of going up, keeping a high chance of them going down if they had any sort of medical history. So these are things that could be informative to clinicians and definitely help in the decision making into prioritizing people in the treatments or having some good decision support tools. There are some other covariates as well, like the psychosis experience. Again, if someone had a yes, it's easy for them to be going up, similar to the childhood development. And this is the tripartite. So there are different categories here, but one is if someone had issues with anxious depression, the other one's for developmental psychosis, and then manic fatigue. And here is just perhaps good to diagnose just if the person didn't have these recorded for the data. And one thing to keep to notice here is the third category here. If they come in with manic fatigue, there's a high chance of them going down. So these people should have high priority in their treatment. Another kind of result to look at is also the posterior for the cluster assignment parameters, the files that we had in the previous slides. So some of the covariates turned out to be more important than others. As I had shown before, for the down cluster, the medical recall, so whether the person had a history, a medical history, is significantly higher. The parameter for that covariate compared to the others. And one thing to keep in mind is that because the model uses exponentials, it acts like a soft max. So it's like a max picking the maximum out of these covariates. And even small changes can denote significant changes in the predicted probabilities. So medical recall, then the circadian rhythm disorders, they also didn't show the posteriors here, but they have higher chance of going down if there is any issue with these disruptions in the circadian rhythm, or they have sleep problems. And for going up, there is the need. So one thing with needs, that's the not engaged in education or employment or training, it is very correlated with the SOFAs. So if a person was not had a need as yes, so they were not engaged in employment or training, they are probably going to the clinic as already a lower SOFA score. So it's more likely that they will be going up because they will have more issues, and the clinicians will probably be giving already more attention to the person, or they would be harder for them to go even further down, at least in this case. So here's some predictions again for some of the individuals. So again, this is important shown in the beginning. For this person, you see that sometimes we should have a very high chance of the person predicting a person is staying constant. But one thing to keep in mind is that most of the data sets composed for the short time frame of 3 months. For most people in the data set, they haven't had time yet to change their response to something higher. So over a short time window, most people are staying constant, right? And there's a few people going up and a few people going down, right? But most people are going constant. So regardless of the individual, regardless of the covariates, the model is always going to assign some relatively high probability of the person to be constant just because most of the people in the data set are constant. But so one way to get over this is instead of looking always at the maximum probability, is to look at whether the probability of a person going down is significant, right? Even if the constant here was high. Right? So this is one of the tools that we are implementing for the evaluation of these models. There's some other cases as well here where the model sometimes doesn't predict very well the slope, because the maximum likelihood slope here would be something very high. You see that the person went from 70 down to 40. So this is a 30 slope points change in 2 months. So it would be like a slope, maximum likelihood slope of 15 or minus 15. That's out of the range here. But the model still was able to predict that the person was more likely to go down based on their covariates. So sometimes even the slope, if the trajectories are not very well predicted, we can still make a good guess on the outcomes of the treatment for a given individual. And sometimes, of course, it's also possible to get things wrong. In this case, the person was going down, but there was a high chance of them going up because sometimes they are outliers in the data. And other times, most of the times when the person is constant, we are usually, the model can usually figure out that the person has a higher chance of staying constant in their response. So another evaluation metric we are using is a ROC curve, so the receiver operating characteristic. So this is basically a plot of the false positive rate by the true positive rate. When we're changing a threshold here, the way that we implemented this was to, out of the cluster assignment probabilities, like here, these 3 probabilities that we have, we're putting a threshold on the probability of the person going down. So if, for example, the person has more than 10% probability of going down, this might be significant, and then we are classifying that person as going down. And we are changing this threshold from all the way from 0, from 0 all the way up to 1. And that's what this ROC curve is showing here. So ideally, we want the ROC curve to be closer to the point of 0, 1 here. So the higher the area under the curve, the better. And this dashed line is what a random classifier would do. And this ROC curve is for assigning putting these thresholds on the up cluster. So we are interested in this case here in predicting whether a person is going up or not. And in this case, you can interpret a negative outcome as a person staying constant or going down. And in principle, we don't want people to stay constant or go down. We want the treatments to have an actual positive response on the person. So it's good to try to have a true negative rate high in a sense, so that we can detect whether a person has a high probability of going down. So if we run this ROC curve, we get this confusion matrix here, and we see that we should have a high diagonal component here, so a high true positive rate and a high true negative rate. But sometimes you can still make some mistakes, but over a relatively small number of data points. This test was done with a balanced data set, so we make sure that we had equal number of people going up, down, staying the same, so out of the real data. So to do that, we basically run the maximum likelihood estimation for the slopes and did some classification on that, and then use that as kind of a reference to what is confusion matrix and the log curve here. We can do the same for the down cluster and get this, and in this case, we see that we can get a good true negative rate. And yeah, so that's it. So we got some, we are running at the moment some experiments using conditional intercept prior. So the intercepts of the, so the initial score now is going to be dependent on the cluster. And we're getting better log curves with some better estimates, but the results are not yet available here. And this a journal paper on the way and other things that I think Frank mentioned, and also some better models of how to infer the covariance by using Bayesian networks. The Matthew Verdell, one of the data scientists working with us, is working. And that's it from me. Any questions? I'd be happy to answer. Yeah. Thanks.
Thanks, Rafa. Thanks, Frank, as well. Very interesting. I've got a few questions, but let's, I guess, open up before that to other people. I'll get the ball rolling first. So I've got a question about the choice of, you know, the up, down, and then the constant. So why? I mean, the lambda, the delta there is basically assumed like zero, the slope of zero. And I was wondering whether this is a very strong assumption. I mean, I would, if I look at something that changes very slightly, is that going to fall under the delta there, or it's going to be classified as a, let's say, negative slope?
Yes, so a very small change. There are two possibilities, right? Either it could be inferred as a constant, and this change could be seen as noise, because we still have a noise model there that we infer in the variance also from the data. So the model could adjust to noise and infer, see these small changes just pure noise, or assigning the person with a small probability of going to the up or down cluster, depending on whether the slight changes change going up or change going down. Right, it's just one of the things that we are doing in this model is with these gamma distributions that we are placing for the slopes, we are making sure that their probability mass is not too close to zero. Otherwise, you would have people from the up and down clusters contributing to the constant cluster, and that causes problems in the inference. So you want to really detect whether the person is really going up or really going down. So yeah, in that case, I think it's just very small change would be seen as noise in that case.
And so and the gamma, so the hyper prior that you do Bayesian optimization on is on, for example, the gamma priors, the coefficient of the gamma functions, or?
Yeah, it would be more on the coefficients of the gamma distribution in that case. And there was also some other hyperparameters, like for the phi's, the cluster assignment parameters, the variance had a hyperprior, so there's some parameter that you couldn't that you can estimate as well. And the noise model as well had its own hyperprior.
And what is the objective of the BO step?
So it would be the log likelihood of
Okay.
responses.
Okay. There aren't any questions. I've got another one about the logistic regression intercept. So does it have a meaning? I mean, I'm trying to figure out, I mean, sometimes I know when I use logistic regression, let's say mapping, this means some sort of it gives you the imbalance in your data set. And then you, in the mapping setting, you actually set up to 0 typically, because you don't want to have this bias. Does the intercept here has some sort of meaning into that?
You mean the intercept for
The logistic regression. So when you plotted
that
the logistic regression coefficients, you had one of them was the intercept.
As far as I understand, that would work more or less as a base probability for like an overall probability for that cluster. So even if all the other the covariance is 0, that's what the one that we will still make sure that that cluster doesn't have a 0 probability for that person, right? So if the person had no answers for the needs, for the medical history and everything else, the probability of that person going up would be the intercept, the exponential of the intercept parameter over 1 plus the normalization. Right. So that gives the like a kind of like a prior probability for that cluster before seeing the data.
So essentially, it is the difference between the weight of each of the groups in that sense, or the clusters, because the prior weight of each of the clusters, basically. That, if I understand correctly.
Yeah, would be the probability for
each of the cluster without the other kind of other parameters.
Calling it a prior is even a bit misleading, but it's more like if all the covariates are 0, like a no, answer is no, and for some of them it's the 0 doesn't mean no, like the tripartite, then the 0 would mean I think anxious depression, right? If everything's 0, like that's the intercept is what defines the probability for that given cluster, right? So it's like it determines the probability of a cluster when all the covariates are inactive.
Okay. Well, that's more or less what I had in mind. Maybe a last question about causal inference. So I know that Andy was working on causal inference for child obesity, and I'm kind of wondering whether, do you think, I mean, I'm not sure you that familiar with, I'm not that familiar with the project, but whether this is that's an avenue here as well for doing something on the same idea.
Yeah, so we have another piece of analysis being conducted with Rafa, Roman, and another senior data scientist in our team called Matt Varadil. He's working on applying some of the work that Andy's done using the directed acyclic graphs to look at causal inference between time point 1 and time point 2. And in those models at the moment, he's just looked at any 2 time points next to each other over the course of that follow-up period and looking to infer whether, T can predict change in T plus 1. So there's some interesting results coming out of that. So maybe we can line that up for a separate seminar series potentially in the new year or something. And we can happy to share those results, which again, Rafa, Roman, and Sally and Andy are all involved in as well.
I already booked you for that, so.
Oh, okay. There you go. That's a good cliffhanger to leave it on, to make sure people come back for the next one.
Okay. That's something in the chat, maybe. Okay. Yeah. So, any other questions before we? Oh, it's awfully quiet. Okay. So Frank and Rafa, thank you very much. It was very interesting. We hear about this project, every Monday. We're like a very short update, and it's always interesting to see what's going on. When I joined there, I heard about it I started hearing about the idea how to analyze that, but I dropped to something else instead. So it was very interesting. So thank you very much for both of you. And I know you have to push it up in your schedules. And so I really appreciate that. So thank you very much. It was great.
Thanks, man.
Thanks for having us. Really appreciate it.
Thanks, guys.
Thanks, guys. Yeah.
See you later.
Bye.
Thanks. Bye-bye.
Bye.
Bye.